In this video, I want to show you how to set up the simple direct media layer, a game library that we will be using to develop games in the rest of this course, and that you are likely to be using for a long time throughout this education and probably through your career. It's open source and cross-platform, and it's used in a lot of games all across the world, both AAA commercial productions and independent game developers. So let me just launch Visual Studio here while I'm talking. This is the website for libsdl.org. If you reload there, you can see various games that have used SDL over time. There are some big titles, some smaller titles. It's pretty awesome, to be honest, though. SDL is both lightweight but powerful. It's relatively simple to get into, but also super flexible. And, you know, you can choose how much of it you want to use. In our case, we're going to use it to set up, you know, a window on our desktop computers, to draw into that window and to get inputs from keyboard and mice. Maybe timers and some of the other subsystems will be used as well. Two important things here. The first is the wiki. This is where you find all the documentation. This is where you learn about SDL properly. Our course will only scratch the surface. This is where you go to check all of your assumptions. Most usable, at least for me, is the API by name category. API is application programming interface. In this case, it just means all the functions, all the constants, everything that is available to you in a long list. So that SDL init, for instance, is a function I know we will need because that's the function that launches, or rather initializes SDL. So if I wanted to know how to use that correctly, I do Control F, SDL underscore init. That's the function, click on it. This way, you can sort of use Visual Studio and the tooltips to see various symbols. And when you see a symbol, you don't know what it is, you can go here, look it up, and you can immediately see. So SDL init, here's what the function is and what's supposed to do. Here's the actual declaration. We see that it returns an integer. We see that it takes unsigned integers as flags. So now we want to know, what is the return value? I mean, what does the return value mean? How do I interpret it? And I want to know, what are the flags and what do they mean, right? Which ones do I want to use? So we go down, we see here that the return value is 0 if everything is successful, and it's a negative value if anything went wrong. And I see that I can call SDL get error to find out what the error was. That's powerful. That's good stuff to know. There is some sample code generally in all of this. And if you scroll further down here, you can see what the flags are. These are some predefined constant that we can OR together. We are probably going to use SDL init video because that's what we care about. And once you initialize the video subsystems, like it says here, it also gives us events. And we're going to need events to get keyboard events and mouse events and other stuff that we care about. Anyway, the documentation is important. The details that I just rambled off is not important. What is important is that you bookmark, you know, the wiki, and that you learn to search this to check your assumptions. Assumptions is the mother of all fuck-ups. So whenever you are unsure, and even when you are sure, go to the documentation and check that you're using the functions the way they were meant to be used. All right, back to the front page. Here's the SDL again. You want to make sure that you download version 2. That's the most recent one. And when you ask for help online, make sure that they are talking about the latest version 2. We don't want the source code because we don't want to build the entire library. We want the development library, which contains some precompiled object code for us. And I'm using Windows and Visual C++. If you are on another editor or another operating system, there is a version for you, but you're going to have to sort that out yourself. Many of the steps will be similar, though. Here's the zip file. Open that up. We have SDL2. It contains documents, includes, and libs. Those two folders are what we care about. The includes are the headers. That's all the declared symbols in this library. The libs contains libraries, compiled object code, and the DLL, which is the runtime. It is an executable. It's what Windows needs, is what your operating system needs to run an SDL application. So we're going to have to tell it where that is after we've installed it. So let's go to Visual Studio and create a new empty project. not a console project, just an empty project. Call it whatever you want. I'm going to put mine in the temp. You can put yours wherever you want. Let's call this SDL test. That already exists. Well, that's what you get for cheating. Go to the temp folder. Let's delete the old one. And back in action. So there we go. We have an empty project. Let's bring in a simple new item, a CPP file. I'm calling that main. And let's just type in the default main function. This will cause us troubles because SDL declares its own main function. So SDL will be initialized first to run some setup code, and then it will run our main. And so we have to make sure that our main matches the expectations of SDL. And well, as luck will have it, SDL's expectations is also the canonical way of typing or of defining main. So main normally takes 2 arguments, and so far we've been ignoring them. And all of that ends up meaning that this version of main will cause a linker error. And I'm going to keep it this way and then generate that error so we can look at it, and then we look at how to fix it, because I want you to see what a linker error looks like. One thing we can type in here, though, is say include IOStream. This is with brackets, the way we do when the header file is a system file or part of the standard library. When we include a local file, like the SDL header, we use ordinary quotation marks. So SDLH is a file that we want to bring in, but it isn't available yet, and so that's why we get the red squiggly line. The compiler doesn't know about this file. So let's bring the file over. If you right-click your project, SDL test in my case, and go to Open Folder in File Explorer, it brings it up here. Here's our main file. Here's the Visual Studio project file. So that's why we know this is the project folder. Go up 1 level. Here's the solution file. That's this level in the Solution Explorer. You can have multiple projects in one solution, though don't ask me about it because every time I try, I break things. In the solution folder, I will create another folder. I'll call that external. And inside external, I will create a folder for SDL. Just to keep, if I have different libraries, I want to keep them apart maybe. And inside SDL, I'm going to bring in the include and the lib folder. The include, I step in here so that I can copy the path. This is the full path to these files. And then I go back to Visual Studio to tell the compiler. Open properties on your project. On your project. Before you change anything here, make sure that your configuration is set to all configurations. There is one setting for when you run it as a debug application, one when you build for release. We want to make sure that we target all of them, both of them. Now, to bring in the headers, go to Visual C++ directories. There is a setting for include directories here. That's what gets scanned for these commands, right? So you click that arrow to edit and add a directory. And that's the full path. Now, the full path is easy, but it breaks if you try to send this project folder to a friend. Say you want someone to help you debug. So you clean your project, you zip it up, send it over, and nothing works for them. And the reason is their file path will be different from yours. You need to make this a relative path instead of an absolute path. And the easiest way is to replace the early part here with a template, a placeholder that Visual Studio replaces for you automatically. So we can replace this folder up here from dtemp and SDL test. That's the solution folder. So we can replace that with the $, open close parentheses, and inside the parentheses we write solution dir. Solution dir is the solution directory, and this will be replaced with, actually we can, if we unhighlight it and then go back to it, you can see what it evaluates to down here. So you just want to make sure that that matches where your header files are actually kept. And if it does, then you're good. Specifically, you should notice that solution dir does not need a trailing slash. If I add one like that, I get 2 here, which is, you know, 1 too many. So I remove that again. Close that down. So that's the include directories. We can double check that by clicking apply, okay. And now Visual Studio will start scanning those files anytime. And once it's done, the include stops being read. So now we know we have found this file, we can start using it. If you wanted to look at the source code, you can right click here, open document, and here's the header. So now you know that that setting is working well. Next, we need to tell it where, we need to tell the linker where our library files are and tell it the name of the libraries we want to use. So back to properties, go down to the linker, go to the general settings. There is a setting for additional library directories. We take that, we edit it, we add a folder. We just go to SDL test, external, SDL, lib. There are 2 folders in the lib folder, right? x64 if you're building a 64-bit project, x86 for 32-bit projects. We are running 32-bit projects, so we're going to go down there. That's what we need. And then again, we replace the early part here with the solution dir template. So $solution dir. I mean placeholder, not template. So that this path still keeps working even if you were to move the solution folder around. Visual Studio will just replace it with wherever it is right now. That's okay. And then we need to go to input and tell it the name of those library files that we need. Additional dependencies is the setting. Go to edit. We can go back to the folder here. Lib x86, these are our libs. We want SDL2 main.lib. Make sure you get the file ending as well. Sorry, so go back here. SDL2 main.lib and SDL2.lib. There we go. Those 2 are all we need. Then a third setting that you need to do is activate the console subsystem so that we get our output and can keep the output. So go to linker system subsystem, turn on the console subsystem. Apply all of that, click OK. And so now, if I compile, I should get at least 2 errors. First, we should get a linker error for our main being a mismatch. And then if it runs, we should get a DLL error. It's a runtime error because the system can't find the DLL file that our application needs. So Control F5. Here we go. This is a linker error. They are generally tricky to decipher, but in this case, we know perfectly well what the problem is. You just need to know that when it complains like this, LNK, whatever, it's a linker error. In our case, what a main function normally takes is 2 arguments. The first is an integer with an argument count, and the second is a list of old C-style strings, normally called argument v, like that, argument vector. So this is a built-in array, which is a type of data container you don't want to use, but is frequently used in C. The problem with this compared to a standard array or standard vector is that it doesn't know its own length. That's why we get the argument count. So this tells us how long this list is. And this list contains char pointers, which is basically old C strings. C strings are horrible for the same reason that the built-in array is horrible, in that it doesn't know its own length, but they have a custom encoding thing with a null byte at the end, which means that sometimes you're able to interpret them correctly without crashing your system. You shouldn't be using them. You will see them a lot in C code. We can tolerate them. But when you need a string, just use a string. The char pointer horrificness is in the days behind us, thankfully. If you wanted to look at what these arguments are, though, we can do that, just the same as we do with any ordinary array. If we do a for loop, int I equals 0, as long as I is less than argument count and I++, step from 0 up to argument count, right? Then do standard cout. We want to print from argv at position I, add a new line there. That should print out whatever arguments we were provided. Now, with this addition to the signature, sending in these two arguments, we don't have to use them, but by adding them here, we have fixed the linker error. So if I run this now, it should execute, but it should crash because it can't load the DLL. So Control F5, bring this up. Indeed, system error, looking for the DLL. It wants SDL2.dll, and the easiest way to fix that is to put it next to our executable. So we go back to the library folder, and again, we make sure that we're working in x86, i.e. 32-bit project files. I want the SDL2, cut that out, go up to SDL test, go into SDL test. Again, here's the Visual Studio project folder. I want to make sure our DLL is next to that. This is the correct folder to be in. Generally, when you distribute your project, you probably want this to be next to your executable, but when Visual Studio runs our project, it will run it from here. Actually, I'm not entirely sure how this works, but putting the DLL here will make sure Visual Studio finds it, or that your application finds it when run from Visual Studio. So, Control F5, here we go. This is the output, too small to read, so let me bring that over. It said, well, it didn't. Okay, let me rerun that and copy paste properly this time. There we go. That's the output we got. So we got one argument sent into our program when it launched, and that argument was the full path to its own executable, i.e. sdltest.exe. This is our own program. There are many other types of arguments one could take, especially for console programs. These types of arguments are frequent and common and powerful and useful, but if you ever need to parse arguments from the command line, you should probably use a library to parse this instead of doing it manually. Anyway, at this point, we have SDL set up, installed in a project, and we are ready to move on and actually build a game. So the next couple of steps will be to initialize the library, tear down the library, clean up after ourselves, create a window, draw into that window, take input, and then figure out how to write games. So we have a fair few things left to do this week, but make sure you have SDL up and running in a Visual Studio project before, we meet next time. Have a good evening.